Okay, so this is a video to show how to work out the lowest common multiple of 5 through to 11. So what we do is we have to make some things called factor trees, which took me a little while to work out how to make. So I'll just go through and do them, and hopefully be able to pick up what I've picked up as I go. So to do a factor tree of 5, we have to try and work out what the factors of 5 are, which there's actually only 2, which are 1 and 5, because 5 times 1 is 5, and you can't break the 5 any further. And in these factor trees, we're also trying to circle all the prime numbers that we get down to when we make one. So 5 is a prime number here and 1 is not. With the 6, there's 2 branches that we can make to begin with. First of all, 1 times 6 is 6, and 2 times 3 is 6. So far we've come up with some prime numbers here, and this here would be the same as what's here, so we don't need to continue this any further, but for argument's sake you could have 2 times 3 and have the same thing, but they both make 6 anyway, so it can be left like this. For 7, only 2. 1 times 7 makes 7, no other multiples of 7, and 7 is a prime number. With 8, 2 branches, same as 6. 1 times 8 is 8, and 2 times 4 is 8, and 2, we've come to a prime number here. This 4 can be broken down further to 2 times 2 is 4, another 2 prime numbers. If you kept going on this one here, you could again do the 2 times 4 and the 2 times 2. So on this one you can note that there's 3 2's, 2 times 2 times 2, 3 prime numbers, 2 times 2 times 2, to get to 8. So that's important to note here. With this one, we have another one with 2 branches. 1 times 9. 1 times 9 is 9, and 3 times 3 is 9. 3 and 3 are both prime numbers. Again, on this one here, if this 9 was going to be taken down any further, it would be the same as what's on this side. 3 times 3 is 9. So what's important to note is that the prime numbers 3 times 3 make 9, and they're all prime numbers. With 10, a double tree again. 1 times 10 is 10, and 2 times 5 is 10. So here we have prime numbers of 2 and 5, because as we know, 2 can't go any, no more factors of 2 that are prime, and 5. With 11, it's 1 times 11, and 11 is a prime number. So what we do with this information, and what I do, is I start with looking at which ones are circled and start at the lowest number. So we've got 2's, then it'll be 3's, 5's, 7's, and then 11's. So we'll start at the lower end of those. So we'll start with 2. So to get the lowest common multiple of all of these numbers, there is at least 1 or more numbers that need a prime number of 2 to get to the 5 to 11. This one doesn't need any, but this 6 needs at least 1. The other ones that are circled in this tree is a 3, so it's just 1 here. This one doesn't have any 2's circled. This one has 3, so 2 times 2 times 2 equals 8. So this one needs 3 2's. 3 prime numbers of 2 to get to 8. If we looked at this one, there's none. This one, there is 1 again. This one's none. So we actually need 3 to get to at least 1 or more of these numbers. So 2 cubed is 3 times. So then we'll go to the next one, which is 3 that's circled. So out of each of these, this one needs 1, none, none. This one has 2, none, none. So this one needs more than 1, so we need to account for that. So 3 times 3 equals 9. So we need at least 2 9s. 1, 2 there to get to the 9. And that accounts for this one that needs 1 because there's 2 there. The next one on the list is a 5 going up consecutively. So we need only 1 5 out of all of these. For this one here and for this one here. This goes with a 2, so I've already got a 2. So that covers that. And also we need it's a funny little dot, sorry. Being a bit temperamental. The next one circled consecutively is a 7. The next prime number is 7. And there is only 1 that we need to include here. And finally, now we're up to 11. We also need 1 11. So if you did this multiplication, 2 cubed times 3 squared times 5 times 7 times 11, you would come up with the lowest common multiple of all of these numbers. Just do it on my calculator. 2 times 2 times 2 times 3 times 3 times 5 times 7 times 11, and I get 2, 7, 7, 20. And one way just to check that is to then put this number into your calculator and click divide by 5 and make sure that it goes in evenly without getting a decimal point number. 6, same with 7, and 8, 9, 10, and 11. So for example, 2, 7, 7, 20 divided by 11 comes to 25, 20 on my calculator, an even number. With all of those, did the same thing, so that's how I've come up with my answer.